So in this segment, we are again going to solve a few questions based on trigonometry. Let us quickly revise what all we have learned in trigonometry so far. We have learned that trigonometry is applicable to all sorts of triangles, but right now our scope is limited to right angle triangles. This is a right angle triangle ABC, which is right angled at B. Let's mark this particular angle with theta. So this is the symbol for theta. Just like you have variables assigned in algebra, generally we use the variables x, y, z, a, b, c and so on. Similarly, for representing angles, we use variables like theta or variables like alpha, beta, gamma. So these are the different variables that are used to represent angles. So if I represent this particular angle as theta, we know that there are 6 trigonometric ratios for this angle. So let us note those ratios. Sine theta, then we have cos theta, then we learned we have something known as tan theta. Sine theta, the short form for it was saw. A way to represent it or a way to remember it. The short form for cos was ka and for tan it was toa. So sine is represented by opposite upon hypotenuse. So it is the ratio of the opposite side to the hypotenuse. Cos is the ratio of adjacent side to the hypotenuse. Tan is the ratio of opposite to adjacent, right? And that is how these short forms have come up, saw, ka and toa. Sine is opposite by hypotenuse. So sine is opposite by hypotenuse. Cos is adjacent by hypotenuse. And tan is opposite by adjacent. So this is how we have come up with these different ratios. So in this case, sine theta is going to be with respect to angle theta. AB is the opposite side and BC is the adjacent side and hypotenuse is AC. So sine theta is going to be given by AB divided by AC. AC is the hypotenuse. Cos theta is going to be BC divided by AC. Tan theta is going to be opposite divided by adjacent, which is AB by BC. The reciprocal of sine is given by cosec theta. So cosec is 1 by sine theta. Similarly, the reciprocal of cos is given by sec theta. So sec theta is 1 by cos theta. And the reciprocal of tan theta is given by a ratio known as cot theta. So cosec theta is going to be hypotenuse divided by opposite. Sec is going to be hypotenuse divided by adjacent and cot is going to be adjacent divided by opposite. So these were the 6 trigonometric ratios that we learned in trigonometry, and using these 6 ratios we can find a lot of heights and distances or different sides of the triangle. So when you say that I'm solving for a triangle, essentially what you're doing is you're trying to find the different angles or different sides of the triangle. And this particular topic definitely can help us do that. Now I'm going to pause for a minute and let you take a look at this particular slide, and then we start solving a few questions based on trigonometry. Additionally, let me bring to your notice 2 important things. Let us find the ratio of sine theta upon cos theta. So sine theta is given by opposite upon hypotenuse and cos is given by adjacent upon hypotenuse. So if you divide these 2 ratios, you get opposite upon hypotenuse multiplied by hypotenuse upon adjacent. So hypotenuse cancels and you get opposite divided by adjacent. And opposite divided by adjacent is nothing but tan of that particular angle. So sine theta by cos theta is therefore tan theta. Taking reciprocals everywhere, you will notice that 1 by sine theta divided by 1 by cos theta. So I took reciprocals in the numerator as well as denominator, and I am going to take the reciprocal even in the RHS. So what I get is 1 by sine is cosec theta divided by 1 by cos is sec theta, and 1 by tan is given by cot theta. So these are two important relations that we can conclude. One is cosec upon sec is equal to cot theta. That's one important relation. And the other important relation is sine theta divided by cos theta is nothing but tan theta. So these two important relations exist, and I will now pause for a minute for you to take a look at all this, and then we will move on with our questions. Okay, let us start solving some questions now based on trigonometry. Let's take a look at this question. In a right angle triangle ABC, right angled at B. So consider that angle B is 90 and the other two vertices are A and C. So this is a right angle triangle, right angled at B. It's given that 13 sine A, 13 times sine A is equal to 12. So right now sine A, so the angle is under consideration is basically angle A. I know that 13 sine A is equal to 12. We have to evaluate sec A minus tan A and 1 by cos square A minus tan square A. So to find these two quantities, I should first know the different trigonometric ratios. So from 13 sine A equals 12, can I find the value of sine A? So 13 times sine A basically means 13 multiplied by sine A is equal to 12, which means sine A is equal to 12 divided by 13. So sine A is 12 divided by 13. 13 was in multiplication, it went down to division on the other side. So sine A is therefore 12 by 13. That means the opposite side to angle A is BC. This side is going to be 12K and the hypotenuse is going to be 13 times K, because sine is given by opposite upon hypotenuse. The opposite side to angle A is BC. So BC has to be 12K and the hypotenuse AC has to be 13K. So based on this, now I can use trigonometry. I can use Pythagoras theorem to find AB. So using Pythagoras theorem, I know that AB square plus 12K the whole square is equal to 13K the whole square, which means AB square plus 144K square is equal to 169K square, which means AB square is 25K square, or AB is equal to 5K. So using Pythagoras theorem, I found that AB is 5K. So this is 5 times K. And now it's possible to find all trigonometric ratios, right? Suddenly I now have a triangle whose three sides are known, so I can find all the trigonometric ratios. Let me quickly find the different trigonometric ratios that I need. I need sec A. So let me first find cos A. Cos A. So cos is nothing but adjacent upon the hypotenuse. Which is the adjacent side here? The adjacent side is 5k divided by the hypotenuse is 13k. So this is 5 by 13. This is cos A. And if cos A is 5 by 13, then sec A is the reciprocal of cos. It's going to be 13 divided by 5. So the first subpart is sec A minus tan A. So sec A is 13 by 5. So this is 13 by 5 minus tan A. Let us find the value of tan A. Tan A is given by opposite upon adjacent. The opposite side to A is 12k and the adjacent side is 5k. So kk cancels again and I get 12 upon 5. This is the value of tan. So 13 by 5 minus 12 by 5. Tan A is 12 by 5. So 13 by 5 minus 12 by 5 is equal to 1 by 5. So this is the value of sec A minus tan A. The second subpart says find the value of 1 by cos square A. 1 by cos square A minus tan square A. So I do know the value of cos. Cos is 5 by 13. Now 1 by cos square A is nothing but 1 by cos A the whole square minus tan square A. 1 upon cos A is given by sec square A minus tan square A. Why did I write it like this? Because I know that the reciprocal of cos is sec, right? So 1 by cos A is going to be sec square A. That is 13 by 5 the whole square minus tan A is 12 by 5 the whole square. That's going to be 169 by 25 minus 144 by 25. And if you simplify, this is going to be equal to 1. Because 169 minus 144 is 25. So the answer is 25 by 25, which is equal to 1. So I will pause for a minute. I'll let you take a look at the solution and then I will move on to the next question. Moving on to the next question. Let us take a look at this question. In the given figure, it's given that cot A is 4 by 3. The triangle is right angled at B. The angle under discussion right now is angle A. So let us shade it. Angle A is the angle of reference right now. So we have to find the trigonometric ratios of the other angles. It's given that cot A is equal to 4 divided by 3. Now let us find what is cot. So if you remember, cot is the reciprocal of tan. So if cot A is 4 by 3, then I can say that tan A will be the reciprocal of 4 by 3, which is 3 upon 4. That means with respect to angle A, the opposite side, so tan I know is opposite upon adjacent, That means the side opposite to angle A is going to be 3K. So this angle is 3K and the adjacent angle is 4K, right? And now I can use Pythagoras theorem to find the length of AC. So using Pythagoras theorem, I can say, that AC square is equal to AB square plus BC square, and therefore AB is 4K the whole square plus BC square is 3K the whole square. That is 16K square plus 9K square, which is equal to 25K square. So AC square is 25K square, which means AC is the square root of 25K square, which is equal to 5K. Therefore, the length of AC is 5 times K. Now, please understand why am I using this particular variable K everywhere. See, when they say that tan A is 3 by 4, this is the ratio of the two sides, that is the opposite side and the adjacent side. It doesn't mean that the sides are actually 3 and 4. It just means that the ratio of the sides is 3:4, right? The sides could be 30 and 40. The sides could be 300 and 400. The sides could be anything as long as they are in the ratio 3:4. That is why I am using this concept of common ratio, that if two quantities are in the ratio 3:4, like if the opposite side to the adjacent side is in the ratio 3:4, then the opposite is going to be 3 times some number and the adjacent is going to be 4 times the same number. So that is why I am assigning the variable K everywhere. So now I have found the hypotenuse, which is also 5K, and I need to find the other trigonometric ratios now. So sine A can be written as opposite upon the hypotenuse. So with respect to A, the opposite side is BC and the hypotenuse is AC. So that's going to be 3K upon 5K, which is basically 3 by 5. Similarly, cos A can be found out as cos is adjacent upon the hypotenuse. The adjacent side is AB and the hypotenuse is AC. So AB by AC is going to be 4K upon 5K. Again K cancels and you get 4 by 5. Now because sine A is 3 by 5, I can write that cosec A. So cosec A is again the reciprocal of sine. So cosec A is going to be 5 by 3 and sec is the reciprocal of cos. So sec A is going to be 5 by 4. So I have found out sine A. Let us quickly box the ratios that we have. We have sine A, we have cos A, we have cosec A, and we have sec A. We have cot A. Cot A was given to us, and that is how we found tan A. So these are the 6 trigonometric ratios that I was supposed to find, and I found them. So again, let me pause for a couple of seconds before I move on to my next question. Okay, moving on to the next question. Let's take a look at this question. In a right angle triangle, triangle ABC, okay, which is right angled at B. So let's quickly mark that. The triangle is right angled at B. So let's consider this is vertex B, this is vertex A, and this is vertex C. The length of AC is 20 centimeters. That is given to me. So let me mark that. AC is 20 centimeters. Tan of angle C is 3 by 4. So tan of angle C is basically going to be tan of this angle. So tan of this angle is going to be 3 by 4. So it's given that tan C is 3 by 4. Now we have to calculate the measures of AB and BC. That is, we have to find the measures of AB and BC. So because tan C is equal to 3 by 4, I can now say that the ratio of opposite side to the adjacent side of angle C. So C is the angle of reference. So which is the opposite side to C? The opposite side of C is AB. And the adjacent side to angle C is BC. So AB by BC is therefore equal to 3 by 4. So if two quantities are in the ratio 3:4, I can therefore say that AB, the length AB will be equal to 3K and the length BC will be equal to 4K. That is, the lengths of AB are 3K and the length of BC are 4K. Now using Pythagoras theorem, I can say that, so using Pythagoras theorem, see the values are 3K and 4K. If I want to find the measures of AB and BC, I should know the value of K. If I know the value of K, I will multiply that value of K by 3 and I will get AB. If I multiply that value of K by 4, I will get BC. So now my goal is to find the value of K. So using Pythagoras theorem, I can say that AB square plus BC square is going to be equal to AC the whole square. Now what is AB square? AB square is 3K the whole square plus BC square is 4K the whole square is going to be AC square, which is 20 square. So quickly squaring sides, we get 9K square plus 16K square is equal to 400, which means 25K square is going to be equal to 400. And therefore K square is 400 divided by 25. 400 divided by 25 is 16, which means K is equal to square root of 16. Now square root of 16 can be either positive 4 or negative 4, because negative 4 square is also positive 16 and positive 4 square is also positive 16. But because sides cannot be negative, I will simply discard the negative value. So the value of K is positive 4. So if the value of K is positive 4, this means this side is going to be 4 multiplied by 4, which is 16 centimeters. And AB is going to be 3 multiplied by 4, which is going to be 12 centimeters. Therefore, I can say that the length of AB is 12 centimeters and the length of BC is going to be 16 centimeters. This is how I can find the lengths of AB and BC. So again, what concepts were used here? Tan C was known, so I was able to frame AB and BC in terms of K. And then using simple Pythagoras theorem, I was able to find the value of K. Once I found the value of K, I found the values of AB and BC. So let me again pause for a minute before I move on. Moving on to the next question. If tan theta plus cot theta is equal to 2, find the value of tan square theta plus cot square theta. So if I want squares of tan and cot, I will have to square both sides. So I know that tan theta plus cot theta is equal to 2. Let us square both sides. So squaring both sides, let's see what we get. Squaring both sides, we get tan theta plus cot theta, the whole square, is equal to 2 square. So the left hand side is of the form a plus b the whole square. A plus b the whole square is a square plus 2 times a times b plus b square is equal to 2 square is going to be 4. So what was the idea I used here? It was simple a plus b the whole square. I just use a square plus 2ab plus b square. And now we know that this is tan square theta plus 2 times tan theta, and cot theta can be written as 1 upon tan theta, because cot theta is the reciprocal of tan, if you remember, plus cot square theta is equal to 4. Now from this particular term, from the middle term, you will notice that tan theta and tan theta cancels, and therefore what I now get is tan square theta plus 2 plus cot square theta is equal to 4. This 2 now shifts to the other side, and therefore what you get is tan square theta plus cot square theta is equal to 4 minus 2, which is equal to 2. And hence I can say that if tan theta plus cot theta is 2, then tan square theta plus cot square theta is also equal to 2. This is how I solve this particular question. There is one more way of solving this question, which I am going to show you, but let me pause for a few seconds so that you can grasp what all techniques were used here. The main ones are a plus b the whole square was used, right? This is a concept which is very close to our expansions. And tan and cot, I converted cot to 1 by tan, and then the tan terms cancelled. That was another critical idea in this particular problem. Let me pause for a few seconds as you take a look at the solution. The other idea of solving the same problem is, see, I can convert this cot to tan. So what it means is, I can say that tan theta plus the cot term can be written as 1 by tan theta is equal to 2. So what I have done is, I have only converted the cot theta to 1 by tan theta. So taking the LCM, I get tan square theta plus 1 the whole divided by tan theta is equal to 2. Shifting the tan theta to the other side, I get tan square theta plus 1 is equal to 2 tan theta. And therefore, I can shift the 2 tan theta to the left hand side, and I get tan square theta minus 2 tan theta plus 1 equals 0. Now, isn't this of the form a square minus 2ab plus b square, right? So, where a is tan theta and b is equal to 1. Therefore, this can be written as tan theta minus 1, the whole square is equal to 0, which means tan theta minus 1 is 0, and therefore I can say that tan theta equals 1. So if tan theta is equal to 1, I can say that theta, so now that tan theta is 1, I can conclude that even cot theta should be 1, isn't it? because if tan theta is 1, cot theta is 1 over tan theta, and tan theta is 1, so 1 over 1 is 1. So now if you are asking me to find the value of tan square theta plus cot square theta, it is going to be 1 square plus 1 square, which is going to be equal to 2. So this is the other method of solving the same question. Again, pausing for a minute for you to take a look at this solution. The techniques used here were I converted everything into tan and I got a minus b the whole square. I found the value of tan theta, and once I knew tan theta, I was able to find cot theta as well. So pausing for a minute. Moving on to the next question. Let's take a look at this question. In this figure, you notice that there are two right angled triangles. One is right angled triangle ABC, in which AB is marked as 12 meters and angle ACB is alpha. And there is one more right angled triangle on the right side, which has angle C marked as beta. AD is given as 8 meters. It's given that cos alpha is 5 by 13. So cos of this particular angle is 5 by 13. And it is also given that cos of beta is 3 upon 5. So this angle is 3 by 5. We have to find the length of BD. Now to find the length of BD, what I am going to do is, I am going to split BD into two parts. So one is going to be BC and the other is going to be CD. Now to find the length of BC, I am going to consider triangle ABC. So let's consider triangle ABC first. It is given that cos alpha is 5 upon 13. So what is cos alpha? What is cos? Cos is basically the adjacent side divided by the hypotenuse, which means the adjacent side to alpha is BC. So BC divided by the hypotenuse is AC is going to be 5 upon 30. And because the ratio of these two sides is known, I can say that let BC be equal to 5K and let AC be equal to 13K. That means this side is 5K and this side is 13K. So now we need to find the value of K. So I can say that 12 square plus 5K the whole square is equal to 13K the whole square. So why am I doing this? So this is using Pythagoras theorem. So using Pythagoras theorem, this is what we get. Now why am I doing this? Because using this equation, I can find the value of K. And once I find the value of K, I can find the value of 5K also. That will give me the length BC. So this means 144 plus 25k square is equal to 169k square. And therefore 144 equals 169k square minus 25k square, which means 144 is equal to 144k square. This implies k square equals 1 or k is equal to again plus 1 or minus 1. But because lengths cannot be negative, I am going to discard the value of k as minus 1. So therefore this length is 5 into 1 because k is 1. So this is going to be 5 meters. Right? Now similarly, I need to find the value of CD. So for CD, I am going to consider triangle CED. So let's say consider triangle CED. They have given that cos beta. So cos beta is 3 upon 5. That means this length, cos of beta is the adjacent. So the adjacent is length CD. So cos beta is CD divided by the hypotenuse. Hypotenuse is CE is 3 upon 5. That means the length of CD is 3k and the length of CE is 5k. I can apply Pythagoras theorem now. So I get 3k the whole square plus 8 square is equal to 5k the whole square using Pythagoras theorem. Now again you could have used a different variable altogether because we have already used k. So you could have used m, n, r, s or any other variable. But because we already have found the value of BC, this k is of no relevance now. That is why I have used it again here. So now this becomes 9k square plus 8 square is 64 is equal to 5k the whole square is 25k square, which means 64 is 25k square minus 9k square, or 64 is 16k square, and therefore k square is equal to 4, which means k is square root of 4, which is 2. So the value of k is 2 in this case. So this length is going to be 3 into 2 and 3 into 2 is going to be 6 meters. Therefore, I can say that the length of BD is 5 meters plus 6 meters, which is going to be 11 meters. Therefore, the length of BD is 11 meters. We used these two different right angle triangles to solve this particular problem, and again trigonometry was used over here. Yeah, we used the idea that if a trigonometric ratio is known, we can use the common ratio and apply that common ratio to both the numerator and denominator and find the different sides of the triangle. Of course, Pythagoras theorem also helped us solve this particular problem. So I will again pause. Moving on to the next question. Let's take a look at this question. In this given figure, find the value of tan x, the value of sine y and cos y. Let me just highlight these angles for a minute. And now I am going to pause for a minute so that you can think of how we should solve this particular question. Again, remember, if you want to find the values of trigonometric ratios, you need to find a right angle triangle which includes the given angle. Okay, I hope you found out a way to solve this particular question. Let me do it now. I need to find tan x. So the triangle that I should be picking is this particular right angle triangle because it contains the angle x. What is the definition of sine? What is the definition of tan? I need tan x. Tan is given by opposite upon adjacent. The side which is opposite to x is RB. So that's going to be RB divided by the side adjacent to x, angle x, is SR. Are these values given to us? Yes. RB is 6 units and SR is 5 units. So the value of tan x is going to be 6 upon 5. Quite simple. Yeah. Now let's find the value of sine y and cos y. So now I need to find an appropriate triangle which contains the angle y. One option is to consider the whole triangle ABC. But the problem is I do not have the length of BC. I do not have the length of AC. So finding the ratio might be challenging here. Of course, we can use some concepts like similarity and etc. to find it, but we have not been introduced to those concepts yet. So now I am thinking of another triangle that I can choose. The triangle that I notice is triangle ASR, right? This particular triangle is also a right angle triangle, and so this triangle might help me find the values of sine y and cos y. So let me write the values. Sine y is given by, sine is the opposite upon hypotenuse. The opposite length is SR. So this is SR divided by the hypotenuse is AS. And cos y is given by, cos is the adjacent side, that's AR. So adjacent divided by hypotenuse. So that's going to be AR again divided by AS, right? Now, is it possible to find AR? Let's take a look at it. The whole length AB is given as 18 and RB is given as 6. Therefore, AR can be found out as 18 minus 6, that is 12 units. So this particular length is 12 units. If this length is 12 units, now I can consider triangle ASR and I can apply Pythagoras theorem in that triangle. So let me quickly do that. So I applied Pythagoras theorem and I found that AS is actually 13. So now do we know all the measurements? SR is 5 units divided by AS is 13 units. and AR is 12 units divided by AS is again 13 units. So this is how I find the values of sine y and cos y in this particular triangle. So again, let me pause for a few seconds before I move on. Moving on to the next question. So we have to prove that sine theta upon cos theta is tan theta and cosec theta upon sec theta is cot theta. So let's do one thing. Let's construct a triangle ABC, which is say right angled at B. So ABC is the triangle which is right angled at B, and let angle A be theta. Now let's find the value of sine theta and cos theta. So sine theta is given by opposite. So the opposite side to theta is going to be the length BC. So sine theta will therefore be BC divided by the adjacent side. Sine is opposite by hypotenuse. So sine theta is the opposite side upon the hypotenuse, which is BC upon AC. So this is opposite upon hypotenuse. That's the definition of sine. And cos theta is adjacent. So that's AB divided by the hypotenuse, which is AC. So this is adjacent upon hypotenuse. Now if I divide these two, let's see what happens. I have sine theta by cos theta is BC upon AC divided by AB upon AC. So when I divide these two fractions, what I get is BC upon AC multiplied by the reciprocal of the denominator, which is AC upon AB. Now AC cancels, and therefore what you get is BC upon AB. So BC is the opposite side and AB is the adjacent side. So this is opposite upon adjacent. We know that the ratio of opposite to adjacent side is given by tan theta, right? Therefore, we have shown that sine theta upon cos theta is indeed equal to tan theta. Now, what I'm going to do is to prove the second part, it's much simpler. So, I have sine theta upon cos theta is equal to tan theta. We have already shown this. Let us simply shift the terms to the other side, right? So what I get is the sine theta is in the numerator. It now goes to the denominator. So it becomes upon sine theta. Cos is in the denominator. It goes to the numerator. It becomes cos theta. Tan theta is in the numerator. It comes down to the denominator. So now we have 1 upon tan theta. 1 upon tan theta is cot theta. And here we have cos theta upon sine theta. So I am going to write this as 1 by sine theta into cos theta divided by 1. I know that 1 by sine theta is cosec theta, and I also know that cos theta is the reciprocal of sec theta. Therefore, I get the second relation, which is cot theta is cosec theta upon sec theta. This is the second relation that I have just shown over here. The other way to show the second relation also would have been as follows. I can take the left hand side, which is cosec theta divided by sec theta. Cosec theta is 1 by sine theta. The whole divided by sec theta is 1 by cos theta. This is division of two fractions. So when I divide two fractions, the division turns into multiplication and the denominator is reciprocated. So I get cos theta upon 1 into 1 by sine theta, which is basically cos theta by sine theta, and that's going to be cot theta. Hence proved. So these are some important relations you should remember, that sine theta upon cos theta is tan theta and cosec upon sec is equal to cot theta. One more relation that you should understand is, if sine theta by cos theta is tan theta, then I can also say that cos theta by sine theta will be equal to cot theta, taking the reciprocal on both sides. So these are three important relations that you should always know. So I hope you understood the questions that were solved in the session today. I will pause for a minute for you to take a look at all these three parts, and we conclude today's session over here. Ending today's session over here.